Hey guys, Mr. B here. In this video, we'll be going over the practice problems in chapter 4.3. So starting with number 1, it says complete the table. Alright, so for these ones, we're definitely going to need a periodic table, and I have just pulled one up on the internet, but if you have one available, either the PDF that's in Schoology, or you can also pull up the same one I have here, which is just ptable.com. We're going to need this. So all right, so it looks like here we have some information, and it looks like we're missing stuff. So let's start here with letter A. So we have the element K, which is potassium, and atomic number is 19, number of protons is blank, and electrons is 19. So by definition, atomic number is the same thing as number of protons, which means that A is 19. We have 19 protons if our atomic number is 19. For letter B, so in this middle this column here, this row here, we're missing a lot of information, but it does give us 5 electrons. So if we have 5 electrons, that also means then we have 5 protons. So I'm actually going to fill this out sort of in a weird order, but if we have 5 electrons, we have 5 protons. So D is 5. That means the atomic number, letter C, is also 5. And that means that the element we're looking for on the periodic table is going to have a atomic number of 5, which would be boron. So for letter B, that should be a capital B for boron. All right, letter E. We have the element sulfur. Atomic number is 16, which means that E, number of protons, is also 16. And for F, number of electrons, as long as the atom is neutral, which we are going to assume it is, then the number of electrons is also going to be 16. So same number. All right, letter G. We have the element vanadium. Number of protons it's giving us is 23, which means the atomic number, letter G, is also 23. And that means the number of electrons is also 23. So this is what our chart should look like, and the numbers that should be filled in there. All right, moving on. Number 2, the number of blank in the nucleus of an atom is the atomic blank of that element. Okay, so this again is from the notes, but I believe it is the number of protons in the nucleus is the atomic number of that element. So just some vocab here. Number 3, because atoms are electrically neutral, the number of protons and blank in an atom are equal. All right, so this is going to be electrons. So because atoms are neutral, meaning they have no charge on them, the number of protons and electrons have to be equal because they balance each other out, and that's why we don't have a charge on the atom. Number 4, how many neutrons are in each atom? All right. So to solve this one, we're going to have a calculator and just do some basic subtraction. I'm going to use my cell phone, but you certainly can use whatever calculator you have available to you. So to solve this, for letter A, the oxygen, we're going to take the top number, which is the mass number, subtract the bottom number, which is the atomic number, and the difference is going to give us how many neutrons we have. So we're going to go 16 minus 8. That gives us 8 neutrons in O, and I'm going to say O for oxygen for letter B there, or for letter A. Letter B, we have 32 minus 16, which gives us 16 neutrons in sulfur. For letter C, we have 108 minus 47. Now, I'm not able to do this one off the top of my head, so I'm going to put this in my calculator here. So we have 108 minus 47 equals 61 neutrons in Ag, which is silver. For letter D, 80 minus 35, we get 45 neutrons in the bromine. And lastly, for letter E, we have 207 minus 82. So again, we'll do this on a calculator. And I get 125 neutrons in lead. All right. Number 5, the total number of blank and neutrons in an atom is the mass number. Okay, so this again is from the notes. This is just some vocab here, but is the total number of protons and neutrons in an atom is the mass number. Number 6, true or false, the atomic number of an element is the sum of the protons and electrons in an atom of that element. Okay, so the atomic number tells us the number of protons and electrons, but is not a sum of both of them added together. It is just number of protons. So that is false. Number 7, 3 isotopes of chromium are chromium 50, chromium 52, and chromium 53. How many neutrons are in each isotope given that chromium has an atomic number of 24? All right, so for this one, we are going to have to do some subtraction like we did in the previous ones. And we have an atomic number of 24, which is also equal to the number of protons in chromium. So what we're going to do is we're going to take the mass number of each of these. So for chromium 50, we're going to take the mass number, and we're going to subtract 24 from it, and that will tell us how many neutrons we have. So for chromium 50, 50 minus 24, we get 26 neutrons in, I'm just going to write CR50. CR is the symbol for chromium, so I'm just going to shorthand it, okay? For chromium 52, again, minus 24. So we're going to have 28 neutrons in CR52. And for chromium 53, again, minus 24. And we're going to have 29 neutrons in CR53. So, all right. There we go. Yeah, piece of cake. All right, number 8. Atoms of the same element are identical in most respects, but they can differ in the number of blank in the nucleus. All right, so these are isotopes that they're talking about here. And they will have the same number of protons, but different number of neutrons in the nucleus. Therefore, they have different masses and different mass numbers. Number 9, atoms that have the same number of protons, but different mass numbers are called. All right, well, we just talked about that 20 seconds ago. These are called isotopes. Okay, so they have the same number of protons, different number of neutrons, which gives you a different mass number. All right, number 10, true or false? An atom of nitrogen has 7 protons and 7 neutrons. So if we look on the periodic table, we can find nitrogen here. Its atomic number is 7, which means that yes, it does have 7 protons. However, it doesn't mean it has 7 neutrons. Okay, so this is kind of true in one aspect, but it's not fully true. So we do have to say that this is false. Number 11, boron has 2 isotopes, boron 10 and boron 11. Which is more abundant given that the atomic mass of boron is 10.81? All right, atomic mass, remember, is an average mass using the mass of each individual isotope and their percent abundance, which is how common they are found in nature. So if the atomic mass of boron, which is an average, is 10.81, that would mean that the isotope of boron that is closest to that number is going to be the one that has the most abundance and the bigger impact. So we can say that boron 11 is the most abundant because the atomic mass is closer to 11 than it is to 10. All right, 2 questions left. Here we go. Number 12, calculate the atomic mass of bromine. The 2 isotopes of bromine have atomic masses and relative abundance of 78.92 AMU with the 50.69% abundance and 80.92 AMU with a 49.31% abundance. All right, so to solve this, we're going to take the mass of each isotope, which is in this case 78.92, and AMU. We're going to multiply that by its abundance as a percentage. So 50.69% becomes 0.5069. And then we're going to add that with the other isotope. So that one has a mass of 80.92 AMUs. Multiply that by 0.4931, which is its percentage as a decimal. And we will add these together and see what we get. So 78.92 times 0.5069 plus 80.92 times 0.4931 equals, and we get an average atomic mass of 79, and I guess I'll round to 4 significant figures, so 79.91 AMUs. That is our average atomic mass. So, all right, number 13, given the relative abundance of the following naturally occurring isotopes of oxygen, calculate the average atomic mass of oxygen. All right, so this problem is just like the previous one. They're not giving us super specific masses like they did in the previous one, but they are giving us mass numbers, which we can use. So we'll start with 16 AMU times 0.9976 as that percentage, plus 17 AMU times 0. And this is where it's important we make sure you do this right. So 0.037% as a decimal is going to be 0.00037 plus 18 AMU times, and then again 0.00204 as a percentage. Okay, it's important that we make sure we write our decimals correctly, otherwise our average mass is going to be too large. So let's go 16 times 0.9976 plus 17 times 0.00037 plus 18 times 0.00204 equals, and I guess we'll round to 2 significant figures because this number here has 2 significant figures and all those. So basically we get 16 AMU. That is our average atomic mass. So average atomic mass is equal to 16 AMUs, which would make sense because obviously the Oxygen 16 has a 99% abundance. So pretty much is all that one. All right, that is it for this section of notes and these practice problems. Hopefully that helped you. But again, as always, if you have any questions, make sure that you ask so that I can help. All right, guys, that's it for the chapter. And the next video will be going through the review guide. So I'll see you there. Bye.